Have you ever seen this symbol before? You may have seen it in hospitals or waste containers in industrial areas. This is the international symbol for radioactive waste or radioactive material. In today's lesson, we're going to be discussing radioactivity and ways that we can avoid coming into contact with it in our lives. The first question we need to ask ourselves is, where can we find radiation? Is it everywhere? Where are the most common places we might encounter this? The answer is that radiation is all around us. Bananas have radiation because they contain the isotope potassium-40. This isn't enough radiation to harm you, but it still counts as radiation you encounter in your daily life. The sun also gives off radiation that we try to protect ourselves from. This is in the form of ultraviolet radiation, or UV rays. This radiation can also be harmful if you don't wear proper protection. Now we need to ask ourselves, is all radiation bad? We know ultraviolet rays are bad if we don't protect ourselves, but is every form of radiation harmful? No! There's radiation emitted from all kinds of things, like your cell phone and other small electronics. Your cell phone is an example of radiation that is not harmful to the human body. The difference between harmful and non-harmful radiation is whether it is ionizing or non-ionizing. Ionizing is harmful, and non-ionizing is not harmful to humans. Ionizing radiation can harm you in many ways. Exposure to this type of radiation over long periods of time can cause cancer, birth defects, and lowered immune systems, especially in children. This type of radiation can mutate your DNA. Some places you might find ionizing radiation are in your food and pharmaceuticals, outside being exposed to ultraviolet radiation from the sun, and even in the rocks and soil beneath your feet, which emit radon, a radioactive gas. Non-ionizing radiation is not harmful to humans, but rather harmless. These are lower levels of radiation emitted by things like cell phones, laptops, televisions, and smaller electronics. The next question we need to answer is, what are some of the most common ways that people are exposed to ionizing radiation, which is the harmful radiation? We've already mentioned the sun, ultraviolet radiation, the soil, but there are other choices you can make in your life, such as flying in an airplane, which can increase your exposure to cosmic radiation. The higher up you are in the atmosphere, the more cosmic radiation you're exposed to. Being on long airplane flights is an example of a life decision that can increase your annual radiation dose by putting you closer to cosmic radiation. Another major source of ionizing radiation in today's world might not be as common as flying on a plane or eating a banana, but nuclear power plants do produce massive amounts of ionizing radiation throughout their operations. As we learned in class yesterday, nuclear power plants use nuclear fission to split uranium atoms to create heat, which generates steam that spins a turbine, which spins a generator, which creates electricity that we can use in our homes. The operation of nuclear power plants puts the public at risk for being exposed to ionizing radiation through encountering nuclear power plant waste or having nuclear accidents. The most famous nuclear accident took place at Chernobyl power plant in the northern Ukraine in April of 1986. The number 4 reactor exploded during a malfunction. As a result, it was obliterated to rubble, and there was a radioactive fire that burned for 10 days. The radiation was released into the atmosphere, and it blanketed Europe and the Middle East. This radiation was powerful ionizing radiation that directly affected the health of all people living in the surrounding area, especially in the Ukraine and in Belarus. Pause the video here to complete your pre-lab questions on your Geiger counter lab worksheet that was handed out to you last class. You can re-watch the first segment of the video if you need help finding answers to questions that you may have missed. Restart the video when you're ready to move on to an overview for how to perform the Geiger counter lab in class tomorrow. Here's an overview for how to do the Geiger counter lab in class tomorrow and how to appropriately use the equipment. Each lab group will get a labquest device. It's a handheld computer that we're going to turn into a Geiger counter. Turn it on by pushing the power button on top. You may need to wait a few minutes for the labquest to warm up. While you're doing that, you can get your Geiger counter ready. Remove the radiation detection probe from the bag and find the end that's supposed to plug into the labquest monitor. In order to find the plug-in, you need to flip the labquest on its side and open up the rubber flap that says Digital Interface 1 and Digital Interface 2. Plug the Geiger counter sensor into either of the two ports. It does not matter which one. To use the Geiger counter, you're going to get a piece of fissionable material from the teacher. This could be one of a number of things, which I'll point out to you momentarily. The Geiger counter will tell you how many counts of radiation it detects over a period of time. To use it properly, take the end of the sensor and point it directly at the radioactive substance. This is a piece of radioactive uranium ore. As a result, it is highly radioactive with ionizing radiation, which is why the counts are climbing so quickly. As I previously mentioned, we have several types of ionizing radiation. This is a piece of uranium ore, the same substance that's used as a fuel source in nuclear power plants. We also have other sources of radiation that you and your group may be testing during this lab. Keep in mind that none of the materials we're working with in lab will actually be harming you due to your very, very low term exposure to these small levels of ionizing radiation. Other sources of radiation you may be testing include americium-241, which is found in old smoke detectors. You may also be testing old lantern bags from old propane lanterns, which contain small amounts of the radioactive substance called thorium. Lastly, you may be testing pieces of pottery called fiestaware, which were made pre-World War II and have uranium-based glaze. So how can we best protect ourselves from this harmful radiation? Is there something we can do or choices we can make to stay safe? One of the best ways we can protect ourselves from harmful radiation is through a process called shielding. We can choose different substances to put radioactive materials inside, which will block the radiation from escaping and protect us from being impacted by it. Several different things can be used for shielding. Through this lab, you're going to determine what would be the best at blocking radiation. Once you place your shielding substance over your radioactive substance, you're going to use your Geiger counter directly over the substance to see how many counts per minute you get of radiation. In this lab, you will not only test paper as a shield, but also aluminum, lead, copper, and lastly, plastic. Take a look at your Geiger counter lab handout that you got last class. The introduction explains a little bit more about what's in this video. The pre-lab questions on the front you should already have answered. On the back of your lab handout, there's a data table where you will record the counts per minute that you collected during the lab for each type of shielding over your radioactive substance. You will then write a claim, evidence, and reasoning to support which shielding you think will be the best based on your data collection. Before we collect any data, make a hypothesis using the information you learned in this video and in class to determine which type of shielding you think will provide the most protection from ionizing radiation. Record this hypothesis in your lab handout. Remember, tomorrow is a lab, so please follow lab protocol. No open-toed shoes, always wear your goggles, and last but not least, if you have long hair, make sure you bring a hair tie to tie it back so that it's not in your face. I look forward to seeing you all in lab tomorrow. Thanks for watching.